guys heard that in the last clip, but we got into a tree heavy here to where we got bark behind the bead lock and actually bent the bead lock a little bit. We have some things to fix. We finally exposed some of the weak points of the design and some of the work I did. If you look here, probably not that obvious on camera, but this tire is all bent this way. I didn't mention it in the other video because I didn't realize it, but this tire is pointing out now. We have a toe problem here. We have a camber problem here. So anyway, we already bent this tube here. I knew that it needed a brace this way, but I was planning on fully plating these, maybe dimple dyeing them, kind of triangulate all of that to make it stronger. A little too late, but that's okay because we had to beat the balls off these axles and make sure that these are going to hold up before I invest again in trailing arms. I'm not making that mistake again because this is my third set of trailing arms. Anyway, there's a couple things that need to happen before we even get into the arms is reinforcing the chassis. Keep an eye on this mounting point right here. See all that action? All right, this is undesirable. This is the factory Volkswagen pocket from the original torsion housing that's still here from, I don't know, a mid-60s Beetle or maybe 70s, who knows. I used it because it was already on here and mostly it works. Now this thing's tore up. Someone's torched a bolt out of this at one point and it's kind of only a single shear design here with this end loosely holding the bolt. We have to do better here. I want to put thicker steel on this. It's somehow bending and tearing and all kinds of crap's going on. Plus, it comes loose all the time. I've nut and bolt checked this sometimes twice per ride, and it still comes loose. Because you're supposed to tap this flange into one of the notches on this bolt, and I just don't like the whole setup. Got a set of these 4 jack stands here at an auction, really cheap. They're for actually holding a boat, so that's the V for the bow of the boat, and then I got 2 more. But anyway, it's actually perfect for cradling this to get a little suspension compression so I can pull the rears of these things apart. Might be handy. With an adjustable wrench and a 3/8 hex key, you can pull the brakes off, the axles out, pull the shocks off, and then after this design, pull a whole trailing arm off with 2 tools. That's where I want to be. I don't want to be in this scenario where you have to carry all this weird stuff. I mean, the Volkswagen design is great. It's proven. People have been running the Baja 1000 with this for 55 years, but I'm just a weirdo and I just like things a specific way. And for me, this ain't it. So I'm drawing up some new 1/4 inch thick tabs to make these trailing arm pockets out of. We're also going to put a top plate and a bottom plate across it. And since I'm going to get these laser cut, I just put some tabs on here to kind of dummy proof it. You know, I've got these relief cuts in the sheet metal here. That's going to allow me to fold this really easily, and then I'll just bend it until this lines up. And that way I know that I have my correct 12-degree offset here. So these have 12-degree bends in them. That's what I measured the Volkswagen angle at. It's pretty close. Whether it's perfect or not doesn't really matter. And then we're not going to drill a hole in this back side here for the bolt. Once it's built and fabricated, I'll then project this hole to here. That way if something warps or pulls during welding, there's no binding of the threads. That's the thought there. All fits together nice. There's pretty much no way to make it not square and straight, so now it's ready for final weld out. And now that it's ground and cleaned up, I can now indicate a flat surface here and punch this hole all the way through to the backside. I intentionally left this undrilled in case there was any misalignment. That hole would never line up, so we'll just drill that one ourselves. Punch that through. If all was done right, that will give us our 12-degree trailing arm offset thing. Now we got to figure out the rest of this. So I punched my 3/4 hole in this side as well as this side. Now we can run a 3/4 grade 8 bolt in here. This is pretty tough stuff. I think this is going to hold up well. Really a beefcake, and the factory sheet metal ones have held up for me. Now I am aware that you can buy these aftermarket, but in my case, of course, with the way I built my frame rails, I needed a little different geometry to make it happen. And tapping 3/4 10 is going to be a good time. I am out of breath. Tapping 3/4 in steel is not that fun, but got it in, threaded full deep. I think I sold my internal threading bar with my old lathe, but thinking back, it was probably too small anyway, so got another one on order for when we do make the other part, but this will at least keep me rolling today. All that to make a stupid nut. What I should have did was just buy a 3/4 grade 8 coupling nut and machine the hex off, but I like living the hard way apparently. All right, so I punched a 1-inch hole in here for this nut bushing thing to fit in. So now the thought is, when I mount this on the buggy, we're going to find out where the trailing arm lands and move this into position. So this is going to be my outer stop for my heim joint. I'm going to let the control arm set that depth because at least I know that part is still built to Volkswagen specs. I'm not going to be doing this with a fixture or a jig or anything. So basically I'll tack this in, set my arm up against this, pull it tight to it, put a tack on here, and then take everything back apart. Cut this off, cut all the excess off, fully weld it here, fully weld it here. Then we've got a threaded bracket, and then we'll build a spacer on this side for the other side of the heim joint. That went awesome. Came off easy with the plasma cutter. Just cut it into pieces, one plate at a time, took the grinder to it. We look really good. So this is the thought here. This will then slide into here like this. And the way I built this is it is dimensionally equivalent to my frame horns. So that means it'll get welded to the torsion tube, but then also up here, it will be welded to the frame horn. And maybe a little more on why I had to design it this way as opposed to just buying the off-the-shelf ones is off-the-shelf aftermarket ones, typically they don't have a kink in them. They're just straight up angled. And that would mean that, you know, I can't move this frame rail at this point, so if it's just straight angled, that whole point is going to be moved over here. So it was critical that I retained the stock Volkswagen design with the kink. That way everything lands where it's supposed to, and I can still tie into our frame rail, and there's room back here to remain, you know, for our threaded portion to keep threads in there. So let me get this tacked in. All right, then to answer another question, why is the pocket so wide if you're using heim joints? Well, I have to be able to slide the arm onto this boss. See how that works? I don't remember why I went this way. I think the factory Volkswagen was kind of this way as well, where you bring the arm in and then slide it in. So that's why I need that. But you can see heim joint lands pretty much in the middle where we want it. I'll take measurements and cut down this boss to see where that's actually going to land, and that's going to be the backstop for our arms. I'm still practicing parting on the lathe. Parting steel pieces has always been a challenge for me, but that turned out awesome. That's exactly what I wanted. All right, that's perfect. So maybe you guys can see it sticks out through the back here, so I can weld here, weld here. Got plenty of bolt thread engagement. We got more engagement than we know what to do with. Got that thing all welded in, looks good. I'll explain why there's this threaded hole in just a second here. And here's the spacer bushing for the other side. That is some good welding in there. Might be too early to say, but that's on there. Really happy with this design and how it welded in. So we're tied into the frame horn here, the torsion tube here, all the way around, and welded inside. So this ends up being a brace for frame rail as well as, you know, an important trailing arm pocket. Paint's drying on that. While that's happening, I want to address this. Built this such a long time ago, and my fear was that this stud could always break off of here. Especially when you hit a tree sideways and the trailing arm is pushed inwards, you would think it would want to rip this off. Surprisingly, none of this has failed yet or even bent, but I want to take care of it now while I'm here. So basically I'm just going to put another plate over the end of it, through bolt it, and then put spacers in here. That way it's got to shear a lot more stuff to actually bend this. Love this plasma cutter. Transfer punches are sweet. You can get yourself a cheap set of them if you want. They come in a bunch of different outer diameters, so when you need to take a plate and make another plate that's the same, you already got holes in it, you just find the punch that fits, and then it gives you a perfect center punch in that hole. Alright, so I had to make some bushing material here. I have some bushings, like pre-made guys, but they're not long enough, so unfortunately I had to cut down a piece of like 1.5 inches. My buddy Nick gave me. Thank you for that, Nick. I can't get material today, so it's a lot of extra hogging, but you'll see where these bushings go in just a second. Noticing something here, you can see that this bushing is pretty close to the housing of the heim. And as we cycle it, it doesn't get any better or worse. Yeah, I could change the taper of that bushing. Yeah, I think I'll change the taper on that bushing just so that can't interfere if something flexes. And out here, the trailing arm still fits on its peg, but we have something new coming for that. Essentially, this is going to lay over this like this with spacers and long bolts. This is now welded to the torsion tube, and then this just reinforces everything so this pin can't possibly shear off, or at least without a fight. So with that thing tightened up, I also got these lock plates cut. And basically these are, they just take a hex and have a big slot in them. I modeled it in the computer, so there's no way this bolt can land in a position where the slot won't fit. And then it just takes a 1/4 20 into this threaded hole. That should stop that nut from backing off. It seems like anywhere on any vehicle that you put a bolt as like an axle for a heim joint, it always just seems to come loose. So I torqued the crap out of it, and then this just gives me that little extra layer of insurance that this thing's not going to walk out while we're riding. So here's what I did for the outer trailing arm pockets now. Aluminum spacers. The inner is welded to the factory torsion bar. The outer bolts on. All 10.9 hardware. Unfortunately only 3 because it's broken off. The actual torsion bar is broken off there. Or torsion beam, what the hell is it called? Torsion housing. Torsion housing, that's the Volkswagen name. All right, I've been playing with trying to straighten out this arm. The problem is this upper member is bowed, and when it did that, it pulled this whole top plate in a little bit. So we have too much camber. I was able to bend the arm a little bit with a big lever, but not nearly enough. So you guys, it'd be a little tough to see that, but that bubble's sitting just a little north of 2 degrees there. 2 degrees negative. So basically I've twisted up my limiting strap here to be just a little bit south of ride height, and I would like to see positive 1 degree of camber here, meaning that the tire is actually tilted a little bit this way. The reason being is the way these pockets are designed, it gains camber as suspension compresses. So if we start at positive 1 at ride height, as the buggy squats and you're looking towards ideal traction, the tire will have a flat contact patch. This huge piece of steel to the hub. Now I'm flexing arm a little bit, see what we can do here. Quite a process here with one person, but use the strap to tension it, flex it to the camber I wanted, heat, hit the areas that needed to flex. Now we got to reinforce it. This little simple piece right here, in which I knew I needed, could have prevented all this drama. That's just gonna fit in there and get welded in. That will transfer the load from the shock mount to both tubes instead of just the top tube, allowing that to bow. Something like that. Some 16 gauge, but we want to stiffen this a little bit. All right, how about some dimple dies? So basically this is just 16 gauge. It's so lightweight, but when you stiffen it up with some dimples and you fully perimeter weld it, I think it's going to do a good job for us. Reason being is these tubes have to spread to really bend this arm, and this 16 gauge in tension is going to do very well to like triangulate and lock this all together. So really the only thing under compression is where we put a solid piece of tubing, a couple gussets with dimple dies throughout this control arm or throughout this trailing arm. I think we're going to be in pretty good shape here. So just imagine this on all 4 surfaces of the arm. You know, you might add 6 or 7 pounds to the arm, but I think it would be pretty challenging to bend one of these after adding all this. There's a lot of patience in this, and I could be patient for the first trailing arm, but the fact that I have to do all this again on the second side has me a little discouraged. All right, this one came out sweet. Got the radius nice, tied everything together. Now, it doesn't matter what kind of soda case you make this from. I choose this particular brand because it's cheap, it hydrates me well, not because it tastes good, but the cardboard they make their cases out of is just perfect for cutting these templates. It's just the right thickness, and I have an abundance of it. Trace it out with a marker. I'm just gonna freehand it because it's 16 gauge. You can clean it up with a grinder pretty quick. Alright, get it ground the way you want, get it all fitted up. Lay out my marks of where my dimples are going to go, and then we'll get that drill. Alright, Holes deburred. Looks good. Now, be sure you understand your orientation. So this is our top side, so we're gonna punch the dimple in. If you did it the other way, it would look weird. These are dimple dies. See, I got these from China, from Latest Rage. See what you can buy them for before you go and make one, because just this material probably would cost 15 bucks. I think I got the whole die for 35. So if you can make them cheaper, go for it. I only have two sizes. I got a 1 inch and an 1.5 inch. Usually you would do these in a press, but with 16 gauge, you can get away with a vise. She's all dimpled and sweet. Most guys only do these because they look cool and they think it's race car things, but really they add a lot of stiffness to this plate. Like, this plate is extremely hard to bend now because you've created all these stretched sections. So from a strength perspective, it physically lightens the part and adds a lot of stiffness. I think it's just a win-win, and they're so fast and easy to do. It's kind of a no-brainer. I'm learning in life that strength does not come from one single material or design. Strength comes from how the entire system ties together. And we have to be mindful of weight on this buggy. I don't want this thing to be some overbuilt tank piece of crap. So just utilizing these lightweight gussets, I think, are gonna make a huge impact in the strength of these arms. I kind of see this as like when you're building a house, right? You frame out your walls, but they're just so floppy, right? They have no shear strength. And then as soon as you start screwing that crappy OSB on there, that OSB is total junk, but it stiffens that wall right up. That's kind of my thought with the thin sheet metal here, is that for this arm to deflect, there has to be shearing between the pipes, and that's where the sheet metal is strong, in the shearing direction. So I think that's going to stiffen it up greatly. Up here you've got the frame rails, you know, tying this together. Not really much going to happen here. You got two pipes coming together to one. You're all good there. Now back here we have to leave open because we got to get an axle through here. So that, my hope is that these sections are just so short that really you couldn't bend one of those, or at least reasonably bend one of them. The other side pocket, my buddy Jesse welded this one. You can see he was able to TIG the entire inside of this thing right through the front and back, which is pretty sweet. I was not able to weld mine out that nice, but we'll see. If the passenger side rips off, blame him. Driver side rips off, blame me. You'll notice something new on here. There's additional gusseting up here and up here. The reason for that is when I was straightening this arm that had the toe out, I expected to find a bend up here somewhere or back here like the other side. It actually walked these curves open. So my theory that we could just reinforce from the shock mount forward is apparently incorrect, but that's okay. This arm's all straightened out. We built 10 gauge gussets for the top here, and they all tie into the shock mount. Same thing down here, ties into the original plate all the way out to the wheel face. It leaves us with this from the back. Should be able to drop my axle in here. Axle shaft should clear this tube. And that's pretty much a fully boxed in arm now. Of course, we had to add another 2 pounds per arm for those. So, you know, this adds 20 pounds to the buggy. It is what it is. These are all essential things, unfortunately. This bracket just came out awesome. I have full confidence that that's gonna hold up for me. Going to a double shear setup out here makes me feel a lot better. And then the full boxing of the arms and finally getting the alignment dialed. I got a laser running from tip to tail to mark my center line, got my toe and camber correct. Now everything is locked in. We should be good. Hopefully we can close the book on these trailing arms, at least for a long time. I do have some other plans that they may require changing for, but I need to focus on more important things first. Well, anyway, guys, that's a wrap on this trailing arm reinforcement and torsion housing reinforcement project here. This was not fun for me. I didn't want to do this. I hate doing the same thing over and over again, and the fact that now I've essentially built almost a fourth set of trailing arms. Getting tired of it. But these are the kind of things that make or break a buggy out in the woods. So it's super important. It's just annoying to put all this effort in, and there's really no performance gains. There's nothing you can feel, barely anything you can see. It's just straight up reliability modification. Let me know what you think about this down in the comments. We'll be back with more buggy stuff soon. We're going to finally get this front end taken care of. Front brakes, power steering, rack and pinion steering, longer travel arms, better spindles, maybe another front wheel setup to shave some weight, maybe coilovers, who knows, we'll see where it goes. Thank you for watching Spank Ranch Garage. I'll see you next time.